We're going to begin our subquery examples with a couple of queries that aren't subqueries. So in this case, we're asked to say, use an in operator to show the name and the city of all employees in offices 1, 2, or 3. So here we have an employee name and the city. And in order to derive that information, we had to join two tables together. The employees table joined with the offices table on the condition where the office code from employees is matched with the offices code from offices. Then the rows will be matched. We have an additional filter to say where the office code is in 1, 2, or 3 as the problem states. Recall that this set operator is a nice convenient way of saying the office code is in 1 or 2 or 3. When I run that query, we get the results. And we can see the employees that work in offices code 1, 2, or 3. San Francisco, Boston, New York City. Now we'll try this next query, also not a subquery of course, where we're going to show office code and city for offices where the country is equal to USA. Running this query, we see the cities of San Francisco, Boston, and New York. So these office codes weren't chosen randomly, although seeing the purpose of this, just by looking at the query, it would be a little bit hard to derive. You'd have to know that office codes 1, 2, or 3 were offices located in the USA. Next, we'll combine those two queries in the form of a subquery. So the inner query, we're going to select office codes where country is equal to USA, very similar to this second query that we showed here, with one change. We need to get rid of the city column, because in order to be used in this manner, we need a single column result. We can't deal in the subquery with an in operator with two columns. SQL is going to say, what do you want to compare to? Which of these columns? So we need a single column result to use the in operator. So we have the select office codes where country is equal to USA, and then we'll produce a single column result, essentially this query, without the city column. Running this query, we get the employees that are located in the USA, and it's very clear what the purpose of this query is. Whereas before, a little bit obscure. You'd have to know that 1, 2, or 3 were located in the USA. So the query is more self-documenting, but it's also a query that can be safely socked away in code and continue to work to show us offices that are employees that are located in the USA, regardless of what happens to the office codes. If we add or remove offices for our company, this query would continue to work to show us employees that are located in the United States. We do that next, that is store this query as a view, show USA employees. So we have now a fixed view. Socked away in the database, this query continues to work, regardless of what happens to the office codes. So here we're using the view that we've created here that's also shown up here. In the next problem, we're asked to find the maximum, minimum, and average number of items contained within orders. So recall that the classic models has a concept of orders table. That's the overall order information. The customer name, the order date, the shipping date, and other types of things that are about the overall order. Whereas order items has the individual items contained in that order. Now, in order to understand a query that contains a subquery, I think it's important that you move from the inside out. That is, understand what the subquery does before we understand what the outer query does. So looking at this from query and also looking at the subquery and also noticing that it's in a from clause, recall that the from clause means that the subquery is not constrained in its architecture. Unlike the previous query where we use the in operator, where we're restricted to use a single column, in the context of the from statement, the subquery can return any type of table, a single value, a single column, or several rows and several columns. It's a table. In fact, it's called an inline view. And it also needs a table alias. So we select order number and the count of order number as items from order details. Notice we're using an aggregate function, but we're using an aggregate function with a group by. So the group by order number is going to create bins with order numbers as their labels, and then we'll count the number of orders in each one of those categories. So for example, order number 10 might have 3 items in it. This would come up with order number 10 with 3. Now using that table, we can use the aggregate functions to say min of the count that we came up with, max of the count we came up with, and the average of the items. Here, this would be a floating point number when we average, so we go to floor in order to come up with a whole number. Let's run this query. Oops, let me fix the error here. I continuously use 2 forward slashes for a single line comment. So thinking about this now, we have our, so running the subquery, we have the minimum item count 1, maximum 18, and an average of 9. So useful for business purposes. How many items do we average are in the average order? 9. How many is the most? 18, and the minimum, of course, 1. In this next query, we're asked to show the product name and buy price for all products where the buy price is greater than the average buy price for all products in each product line. This subquery uses a greater than operator, not an in operator in the where clause, meaning that the architecture of the subquery itself, the interior query, needs to return a single value, because otherwise, how would it say greater than? So when you need to return a single value, it's often true that the aggregate function with no group by will fulfill that value. Again, there needs to be only a single column in the select statement. So this is going to be a single column and a single row. We're using an aggregate function, therefore we always have a single row if you don't have a group by, because the entire table is the group, recall. So now we know how this will work, because we can use the greater than operator against a single value that this subquery is going to return. The other important thing to notice about this subquery is that it's a correlated subquery. It has a dependent value on the outside query, namely P1.productLine. They're both going against the products table, so we need to disambiguate the products table name P1 here by giving this a table alias P1 that it's going to use inside here. So P1, once you use a table alias, you have to use it everywhere. P1.buyPrice is greater than, and then essentially that information is also passed into this query. Now notice the overall syntax of this doesn't change. We depend on the MySQL server to analyze this and realize this is a correlated subquery, and it runs it completely differently. These other subqueries, not correlated, can be run independently, and in fact that's how they work. The subquery is run, and then a temporary table is made, and then it's run once, and then the outer query is run against the results of that single subquery. Here, with a correlated subquery, we have a dependency here. We're looking for the average buy price of a particular product line. So, suppose the outer query comes across a train, 1988 locomotive. That's the product name, and the product line is train. So the product line becomes train, and this subquery is run with P1.productLine equal to train. So it's going to show the average buy price for product lines equal to train. It runs the subquery, comes up with the average buy price, and then filters, does this overall product belong in the query? Suppose the average buy price for train models is $100, and this particular train is $95. It would be filtered out of the result set because its buy price is underneath the average buy price for products in its product line. The next train is filtered for. 1883 steam locomotive. Product line is equal to train. It goes into the buy price of this, and it comes up with, okay, the buy price of that model train is $135. It passes the filter, and therefore it belongs in the query. So the subquery is actually run every time, like an interior for loop, for every time this evaluates and comes up with a new product. Let's run it and see the results. So now we see all the product lines, basically these cars and trains and ships, these are all above the average buy price for products in their product line. So we've seen subqueries of different architectures. We've seen subqueries in the where clause, where they commonly occur, with the in operator, a set operator, where we have a single column result. We've seen subqueries in a from clause, where we're not really restricted on the architecture of the table. And we also have subqueries where we're doing a single comparison operator, but also a correlated subquery. Thank you.